So the project for tonight is to continue working on the Z-axis. I was able to buy another set of linear bearings so I can do the floating head portion, work on the floating head. These are the exact same size bearings that I have on the rest of the Z-axis. So I'm pretty much using this size bearing for everything, and the nice thing about that is I'll be able to stock a couple spares, and these are Chinese made bearings, so they're relatively cheap. They're like $10 or $12 for the whole bearing assembly. So a comparable US made bearing would be over $100, so they're a tenth the price, and I'll be able to keep some spares in case these are cheaply, in case they have bad, short service life. But so I have this plate that's going to mount here, and then what I'm going to do is I'm going to have a section of rail here and a section of rail here, and then another plate that will mount on top. So I need to cut this plate down. I need to put a bolt pattern here and a bolt pattern here, and cut it to length, and then cut this rail and mount it up. So that's the job for tonight, is to do the floating head. So let's get started. So for cutting materials, you got a couple different options. When if you're first starting out, you might just use something like a reciprocating saw, or you might even use a hacksaw like I did when I started out. But this is a Milwaukee Portaband saw, so this makes really quick work of cutting aluminum. So this is what I'm going to use tonight. I don't have a print or a drawing or anything on how to make this part, and I don't think I need one. So my plan is I'll look up the bolt pattern, the 4-hole pattern that's required for these, and I'll get the dimensions, and then I'll put it on this plate. I'll use normal dimensions, so something like that. I'll know, like, from here to where the next set of holes is 2.5 inches. So I'll just use regular, ½ inch, 1/4 inch, sometimes 1/16, but I just try to keep it simple. That way, if I ever have to remake the part, I'm not trying to work out what the part was. I'll know when I'll just put a ruler up next to it, and I'll say, okay, that was spaced at 2.5. So I got to get the dimensions for these online, and then I'll start laying the whole pattern out. So this is the picture for the dimensions of these carriers. So it looks like it's a 20 by 20 millimeter hole pattern. So I've got a set of slide calipers. I'm just going to verify that, because I can tell by looking at the bearings that they're not, the hole pattern's not square. So I need to figure out why they have the dimensions like that. But So zero those out. So I am confident that that's 20. Let's see if this is 20. Oh, it is 20. So it is a 20 by 20 hole pattern. Okay, perfect. So that's pretty easy to do. Obviously the milling machine is not metric, it's standard, so I'll convert that 20 millimeters into thousandths and then lay it out. So that should be pretty easy. More than likely my scheme to machine this is going to be, I'll take some rough measurements and I'll figure out where I want one hole to be, and then I will do that hole, the next hole, then I'll jump all the way over and do this hole, and then I'll come down and come back. So that's my plan. I just have to figure out exactly where I want to start. I'm paying attention. I gotta re-zero this and then measure, and it's just about dead on 20. So that's a good hole pattern. So I'll figure out roughly, probably gonna want the holes to be in around 1/4 of an inch on this side. So I'll just dial in. We'll do 3/8, 375. So that's going to be roughly where I want to put start my whole pattern right there. And then I'll, when I get over to the lathe, or to the milling machine, I'll figure out what spacing gets my other set of holes over here. So let's go over to the milling machine. So these are metric fasteners, so I have to find I'm gonna have to, these holes need to be metric, essentially a clearance size for a metric fastener. So I'll take calipers and I'll just measure the size fasteners that go in there, and then find an equivalent drill size. So 114 essentially. So I'll be looking for something around there. So on the chart, 114. So I could do a 32, which would be 116, or I could do a 31, which would be 120. So I'm going to do a 31, 120. That only gives me like 3 thousandths per side clearance, which is not a lot, which will be a really good fit. So, alright, so I got my machine centered on that cross mark that I made. Got my hand wheels all zeroed out to travel that way. So the next thing I need is standard equivalent of 20 millimeters, which is 787 thousandths. So it's always helpful to, when you're working something like this, if you don't have a blueprint, just draw a sketch real quick. Because the last thing you want to do is start poking holes in here and then realize you lost your place, you can't remember where you were at. So I'm going to draw a quick sketch and just put the dimensions on it of what I think I want to do. That way I can reference it while I'm doing the machine work. And that's it. 4 holes, 787.00 on that corner. And then that's enough as a quick reference for me. I don't do a lot of machining work, so I need to make a sketch usually. And the other good thing is you save these. So you put them in your book and you save them, and then you always have them. So if you have to stop on this project or take it out or do anything, you know how your machine was set up when you were doing the pattern, and you can put it right back in, zero it back out, and continue on your work. I don't know what this distance here is going to be yet, but then there'll be another 4-hole pattern with the same spacing over here. So that's good enough for what I'm doing tonight. Because these are clearance holes and everything's essentially locked out, I'm not going to bother center drilling these. I'm just going to spin this up at a pretty good speed. And these are good drill bits, so they're split point drill bits, so they should cut really easily. So very light pressure at first until you get it started, and then you can drill the hole. So that's my first hole, and I'm going to check the size against the fastener I plan to use and see what I think. And that's going to be a really good fit. That's exactly, it's a clearance hole. It's not super tight, but That's perfect for what I want. So I think my plan is to do this whole 4 pattern, and then I'll come over and do the other 4 pattern. So I need to move 780 thousandths. So that's where my next hole should be. So I'll just tap the drill bit on there. It'll make a little transfer, and then I can slide calipers out and verify that distance. So it should be around 20 millimeters exactly. 0 and on 20. And this is just good verification. Again, I don't do a lot of machine work, so I like to double and triple check stuff because I don't want to do it twice. And that looks like it's dead on. So poke another hole. So no fancy tricks here. We're gonna put the bearings under here, and that's 4. So we got a good hole pattern. All 4 little cap screws are started. So that's great. It's a good pattern. Now we just need to tram over and do another one. It's almost like the threaded the threads on this bearing are cut shallower than the threads on the other bearing. So I guess that's what you get for precision $10 bearings from China. So I have to take 2 of these out and see if I can just nip them off with a grinder and then put them back in. I need to take this part and cut it right in the middle. So this rail is hardened, so the best way to do this is with an abrasive saw. I'm just going to use a cutoff wheel and a grinder. So one of the keys when you're making cuts on, I mean basically with any type of saw, is to clamp your workpiece down. And put that little piece of aluminum there. That aluminum is there so I don't mar the surface of the guide up. So like I was saying, you wanna clamp your parts down whenever you can, because that will prevent that from moving and it'll make the cut. It'll cut it more efficiently. Same thing with sanding or anything like that. If you clamp it down, your cutting tool is going to be more effective. Your sanding is going to be more effective. So. So you could clean that up if you want. I'll get the sander out and we'll touch them off the sander real quick. I'll show you how delicate these things can be. So I'm gonna insert this from the factory cut end. That's a lot cleaner. And we'll just gently. You can see how those ball bearings start moving and they start getting out of whack. So you just use your finger in there to see. There's one already. There's one that's already popped out. Well, it's on the floor, it's gone. So just try to work this back and forth and slowly get them in there. Once it's in, it's not a big deal. You just have to work it back and forth. Because once they're in there, they can't. Once they're in there, they can't. The bearings can't fall out. Here's the other one. this is the plate that goes on the machine. So I have to flip this on here. I'm gonna probably eyeball it even, left and right. And then I've got to make some match marks, and I'm gonna mark this thing on here. So I did some measuring and I got a bolt pattern for this. It's essentially almost 3/450 exactly, center line to center line, so that'll be easy enough. And then the holes are spaced 25 millimeters, so I've got those measurements also. So the next thing is these are gonna be tapped holes, so I need to find a drill size equivalent. So you look on the chart, and I'm using an M3x5, and I go over here and I need to find something close to 0984. So you basically got 098 is a size 40 and 0995 is a size 39. So I'd rather have the holes tight, so I'm going to go with a number 40. Alright, so whole plate, I'll get some cutting fluid and the tap and put it in the hand drill, and just drill these out real quick. Alright. There's a little bit of binding, but I don't think it's going to be enough to matter. And I can also loosen these and loosen it all and try to work that out, but with the torch weight on there, it should do everything that I need it to do. So, get that mounted. I need to get some screws. Probably need to figure out. It looks like I've got the backs of these are poking out. I'm gonna have to take the grinder and grind them off so this all mounts. But there it is. That's gonna be the floating head mechanism once I get it finished. The next part will be it's another plate that has to fit on this, fit over this, attached with magnets essentially. That way it can break loose. But that's going to be the floating head mechanism right there. So that's all. That's it for this part. The next part will be making that plate and setting up the magnets and setting up some kind of breakaway. Hopefully attaching this.